Good afternoon, everyone, and welcome to this virtual event. This event is part of University Research Week. Specifically, it's part of the Health of Our State and Beyond series. And today's event focuses on coastal resilience. My name is Amanda Martin, and I am the state's Chief Resilience Officer. But more importantly, I am a UNC alumna. I graduated with my PhD in City and Regional Planning in 2019, and I am thrilled to be the MC for this event. I don't think anyone's ever allowed me to be an MC before, so I'd like to thank UNC for calling me an MC rather than a moderator, which is less exciting. This event, as you may be aware, showcases exciting and interdisciplinary research on climate resilience from what we call a creativity hub. Each of these creativity hubs is an interdisciplinary team of creative, scholarly thinkers that tackle urgent and emerging issues facing the world today. Creativity hubs are funded by UNC's Office of the Vice Chancellor for Research to incentivize this type of interdisciplinary work. In this presentation, we're going to hear from members of a creativity hub focused on extreme weather. The full title of this hub is The Dynamics of Extreme Events, People, and Places, which the acronym is DEEP. And this hub brings together social and natural scientists, engineers, public policy researchers, and data analysts to look at this complex issue from all different kinds of angles, including considering the impacts of extreme weather on health and well-being, on economic hardships, and on environmental conditions. So I'd like to welcome everyone to take part virtually. We have a series of presentations, and then we'll open it up to a panel. And in anticipation of the panel, we invite you to submit questions. There's a section below the video viewer where you should be able to ask your questions. So feel free to start sending questions during the presentations, as well as during the panel itself when we start to do that Q&A. So with that, I will turn it over to Elizabeth Frankenberg, who is director of the UNC Carolina Population Center.
Hi, Amanda. Thanks so much. It's really a pleasure to be here today. So as Amanda mentioned, we're going to talk today about a project called The Dynamics of Extreme Events, People, and Places. We've been working on this for about 2 years, and we'll give you a brief introduction, and you'll hear from some of our scientists from different disciplines, and then open it up for questions and answers. So the problem that we have wanted to address, is the fact that extreme events damage places and have very potentially long-term effects on people of different forms. But data about those events are somewhat limited. We know a fair amount about property damage, but not about some of the other impacts on health and psychosocial health, and also on the natural environment. In addition, much of the research is reactive in the sense that it, it starts after an event, but doesn't last for a long time. It sort of captures a very short-term perspective. And although many different disciplines conduct research in this area, they don't always engage with one another. So those are issues that we have wanted to address. And our approach has sort of 3 aspects to it that we feel is important. One is that we're really trying hard to integrate across disciplines, sociology and demography, which is what I do, but also engineering, marine biology, environmental science, policy and planning, geography. And so we've brought researchers together from these different angles, and we spend a lot of time sort of working with one another to embed these angles into our research. A second thing that we've been working hard on is building a platform for data collection that spans the dimensions of the social world and the natural world, and that also occurs over time as opposed to just one point in time. And then what we ultimately hope to do is develop tools that we can use to predict storm impacts on short and long-term outcomes and model impacts of mitigation and assistance. We began with putting together a conceptual framework, recognizing that an extreme event occurs, there's a response to that event that eventually sort of transitions into preparation, and then another extreme event tends to occur. And embedded within this circle is a set of systems that interact with one another, natural systems, human and social systems, and also the policy, environment, and engineering approaches to dealing with these things. So that's the conceptual framework that we developed to guide the work. The next step was to develop a research strategy. So we're trying to undertake a set of activities that map and model exposure to storms and the risk of being exposed to extreme events, pull in administrative data, and then also develop this longitudinal data collection platform that we can apply in different places. With those pieces assembled, we'll be able to link exposures to various outcomes, and those in turn will generate the understanding of impact that we can use to project long-term change for people and places. The last piece of this is team building and community outreach. So we have a pretty big team. We have faculty involved, but also students, and very importantly, people in the communities that we're working in. And with that, I want to turn it over to one of our undergraduate students, Natalie Johnson, who's been with our team for about a year now, and have her introduce a little bit about the work that she's done with the project.
Hi everyone, my name is Natalie Johnson and I am in my third year at UNC studying political science and economics, and then I have a minor in public policy. I joined the DEEP team about a year ago in November of 2020 after Dr. Frankenberg was actively recruiting students to help open our first field site, which was in Ocracoke, North Carolina. And so I was trained and we opened that site in December of 2020. And so I was a part of that team that headed to Ocracoke, and we went into the field with our household surveys, which, we use to collect data in the community. And so we had selected about 100 different parcels within Ocracoke to survey, and we were going door to door with these selected parcels. And if it was a residential home, we would ask that everyone over the age of 15, could participate in our survey. And I could talk about the contents of the survey honestly for hours, but to be very brief about it, we took a very holistic approach in the questions that we asked. So not only do we ask about, damage to the structure of the home, as well as personal items within the home, but we also asked about, items that the people in the house that they own, the damage that occurred to those items, as well as questions about mental as well as physical health during and after the storm. But then we also ask a lot of questions in regards to COVID-19. In these communities, not only were they hit with a hurricane, but of course, they were also having to deal with COVID-19 as well. And so we combined all these questions into a survey, and we were going door to door to these households asking that they would participate. And there is a moment in time in my experience in the field where I went to a household and I was interviewing a single person household, but I came to the house, and this woman, she had marked where the water line was in her house. For Hurricane Matthew, which was in 2016, as well as Hurricane Dorian, which was in 2019. And my colleague was with me, and he stands to be just about over 6 foot. And the water line for Hurricane Dorian was like right at his chest. And so I think for me, as someone, I'm born and raised in Charlotte, North Carolina. I've lived inland my whole life to where the point I've never experienced a hurricane. So being in the field, speaking with these community members, but then finally seeing that direct impact right there with the water line and how high the water had gone, not only in her house, but in virtually every house in the community on Ocracoke. Not only was that a visual for me, but it was a constant reminder for her in her own home, as well as community members across Ocracoke and other communities in Eastern North Carolina that deal with these natural disasters every year. And so I think that really showed the resilience of the community within Ocracoke after these hurricanes, and really showcased their bravery, as well as the community support that they offer each other. So that's a little bit just about my experience in the field, but I'll pass it on to Rick.
Good afternoon. I'm Rick Ludick, and I am the director of the Institute of Marine Sciences in Morehead City, and also the Center for Natural Hazards Resilience. My work is on computer modeling of ocean systems, and particularly coastal systems. We've developed the what's called the AdCirc prediction system, which brings together the ability to represent specific areas of the ocean, and for example, coastal North Carolina and the Great Sounds that we have here, and how it responds to natural forces such as the tides from the Earth and the Sun and the Moon, the forcing from winds and meteorology, inclusion of things like surface waves and precipitation and runoff. So we bring all of these together and then can predict how the ocean will respond, and in particular how it will interact with the coast and what areas will end up being flooded in the process. This is a widely used system. We make it available to the broader community. It's used for retrospective and forensic studies. Saw extensive use immediately following Hurricane Katrina to try to understand what went wrong in the greater New Orleans area and caused all the flooding there. It's used for hazard assessment, such as the FEMA flood insurance program, to try to assess and evaluate what the risk levels are in coastal areas. It's used for design. If you go to New Orleans, the levees there have been designed by the Army Corps of Engineers using AdCirc, and other areas like Houston Galveston, if they've been trying to figure out what to do there to help enhance their protection, and using AdCirc. And in fact, as more and more coastal areas are impacted by climate change and sea level rise, tools like this become critical in trying to plot mitigation strategies for the future. We also use it for forecasting. And here in North Carolina, we're hit by hurricanes on a fairly frequent basis. Major impacts from Hurricane Florence in 2018 and Hurricane Dorian in 2019. Hurricane Florence came at us pretty much from east to west and made landfall close to Wilmington, Cape Fear, mouth of the Cape Fear River. One of the amazing things about Hurricane Florence was how big it was. And in fact, it had major impacts in the greater Wilmington area and along the coast. But it also had major impacts along the western shores of Pamlico Sound, up into the rivers, the Tar River and the Neuse River, up into the New Bern area and even further inland. The picture in the upper right shows red. The hot colors show high water levels and in fact flooding in excess of 10 to 12 feet in those areas. And so for Hurricane Florence, we can represent its particular impacts in the coastal area. And then Hurricane Dorian, which approached us in a more traditional south to northeast direction. It impacted mostly the southern part of Pamlico Sound, but you can see it also had major impacts on the Outer Banks and in particular Ocracoke, as Natalie just talked to us about. These are really powerful tools, both for forecasting, but also for helping us recreate what happened and try to put the pieces together as we try to understand what nature is bringing to bear and then how people that live in these areas are responding. One of the key things we need to augment our models, whether it's for storms like Hurricane Florence or Dorian, or just for more routine events like tides and lighter storm events, is data. We need data to help us validate and better understand what's happening. And so I'd like to pass on to our next speaker, who will tell us a little bit about some novel data collection activities.
Thanks, Rick. Hi, everyone. Thanks for joining us today. I'm Miyuki Hino. I'm an assistant professor in the Department of City and Regional Planning and the Environment, Ecology, and Energy program. So I will be picking up on the same theme as Rick in terms of our efforts to try to understand where the water is going. But rather than talking just about predicting and especially big storms, I'm focusing instead on measuring and monitoring water levels, even during just routine weekly or monthly types of events. These types of events, so one of the consequences of sea level rise is that even outside of storms, on sunny days with particularly high tides, coastal communities can experience flooding because the water is simply higher than their infrastructure was originally designed for. These types of floods are a little bit tricky to track because they might last for just a few hours at a time. They come in with the tide, they go out with the tide, but they happen so often that they have this chronic disruption to the communities that are experiencing them. So what we've done is we have actually put together custom sensors to track and provide data on what's going on with these smaller events. So on the left here is a picture of our sensor. It's actually sitting inside a stormwater drain. So you can imagine to take this picture, we stuck our hand down into the storm drain. The grate that you see on the road is in the top left. And so our sensor is strapped to that grate and hanging down into the drain. And for an example for how this works, we can actually just take data from this past weekend and even yesterday. So in the top right is a picture that our camera took yesterday morning at around 10:30. You can see it's pointed out over a roadway in Beaufort, North Carolina, where there was quite a bit of standing water. And on the bottom right is what our sensor in that storm drain was recording at that time. So I put a little red star at 10:30 yesterday, November 8th, and you can see that there was about 1.5 feet of water on the road at that time. What's really interesting, you can see from what our sensor is recording, is that pretty much every tide, water is coming into that storm drain. Sometimes it's not going onto the road. Actually, most of the time it's not going onto the road. But even in routine moderate tides, the storm drain system is impaired. And what that means is that if you get any type of rain coming on top of a moderate to high tide, that water has nowhere to go. And so you can get flooding from those combined effects as well. And what's really great about this approach by monitoring the storm drain systems themselves is that we can pick up this type of flooding, whether it's just a tide or a tide and rain, even if it lasts for just 30 minutes at a time. And that's providing really valuable data for us to then really understand the lived experience of individuals and households in these communities, that it's not just the big storms, but also these types of chronic disruptions to their daily life that are occurring more and more as the climate continues to change. So with that, I will turn over to Mike, who will tell you a little bit more about natural systems.
Great. Thank you so much, Miyuki. So our part of the work is thinking about the water and trying to understand what's in the water. And so I'm the director of the Institute for the Environment. This part is collaborative with Dr. Rachel Noble, who is at the Institute of Marine Sciences. And what we did in our section was take on a little bit of an age-old question of trying to understand what is delivered with the water. Not only water that floods up onto land, but water that ends up in embayments and areas where people may be exposed to it. So the picture in the upper left-hand corner is from Newsweek, and the caption says that the pollution was so bad that you could see it. And in fact, the things that are being shown in this picture aren't pollutants. They're part of the function of the natural system. So Elizabeth alluded to the study of hurricanes often having to be a reactive thing. The studies occur after an event has happened, and you don't have a great sense of what the conditions were before it happened. And these are really critical metrics to address because they connect, as we've been talking about, this coupled natural human system. They connect the function of the natural environment to the way that people experience the places that they live. So in the lower left-hand corner, we have our very sophisticated sampling equipment that is very photogenic. Our part of this study that's looking at what is in the water is really focused on trying to understand not only what is in the water after a storm, but what is in the water in base conditions. So conditions that are not particularly rainy or have not been very stormy. And we think this is important because if we can assess the impact of a big storm accurately, it would be really much more compelling if we could understand what was there prior to the storm. So in part, this part of the study was designed to create a synoptic sampling database in case we saw a big event. As is often the case when you do studies like these, you don't see big events. So if we stopped a hurricane from coming, I think that's wonderful. But we did get really interesting data. So if you look on the right-hand side at this figure, the darker the color of any of these dots, the higher the levels that you see. And there are a number of metrics that we were interested in that have impacts not only on the function of the natural system, but could have impacts on people's experiences around water quality. So on the top, we have on the left-hand side, base flow. So when storms haven't been happening, and on the right is storm flow. Total suspended solids, this is sediments. If you look, there are some darker dots on the right-hand side indicating that they were elevated during storms. This makes sense. There's more delivery from rivers and streams, but there's also a lot more mixing that brings sediments into the water column. The next layer down is chlorophyll A, which is an indicator of algae. And interestingly, there's just not a lot of difference between the base and the storm. So the distributions that we see in algae are pretty similar before and after storms. And while I said we didn't get a big hurricane, we did get quite a bit of rain, an 8-inch rain event. And so that's a significant storm for sure. The next level down is nitrate. That's a form of nitrogen, which is important because it tends to limit the plants that grow in the coastal zone. And this includes algae. So if you have areas with excessive nitrate supplies, you often see a response in the metric above, which is a measure of algal biomass, so how much algae is there. Nitrate, again, the patterns on the left and the right, the base and the storm are pretty similar. And the distribution that we see from high to low, those hotter colors, are actually associated with wastewater treatment plants. So this is an area where after the event, during the storm, we don't really see the elevation in this metric that you might expect. And then finally, this last metric is chromophoric dissolved organic matter, CDOM. And this is the black water that you see in swamps and black water streams. And this is actually what's shown in the image in the top left from Newsweek. So it is an important metric to understand because it's a big part of the function of the natural system. It's also really interesting because we can see the patterns that the figure in the upper left shows with an export of black water during a storm and the continued elevation of the levels of black water during the big storm event. So in addition to all of these measures, which are more geared towards natural system function, Rachel Noble, who I mentioned, is making measurements on pathogens and indicators of pathogens to humans. So we'll have this same distribution before and after storms for those pathogens. And we will be prepared if there is a big hurricane to have this great set of baseline data. But irrespective, we'll have this comparison of base and storm, which is really important if we're going to understand not only how the natural system changes as storms come through, but also the potential function changes that affect people. So now I'm going to hand it off to Anne Smiley, who is going to talk a bit more about natural systems.
Thanks, Mike. Hi, everyone. My name is Anne Smiley, and I'm a graduate student at UNC in the Earth, Marine, and Environmental Sciences Department. And I'm going to talk to you all about natural systems and how they can help minimize some negative storm effects and contribute to coastal resilience overall. So habitats like oyster reefs, seagrass beds, salt marshes, all naturally perform all kinds of functions that support, protect, and generally benefit coastal communities. We commonly refer to these functions as ecosystem services because they are super valuable to us. And they include stabilizing sediments, attenuating wave energy, storing surface waters, and processing nutrients. And all of these services are really important under ambient business as usual conditions, but they're really, really important when a storm comes along. And when a storm does come along, these services act to minimize land loss and infrastructural damage and reduce flooding and regulate water quality. Our group is particularly interested in the water quality aspect of all of this, more specifically nitrogen cycling. And just to add a little bit of context, nitrogen in excess in a water column can be damaging environmentally, economically, and with regard to public health. So keeping those concentrations in check is really important. And natural habitats like marshes and swamp forests do just that. They're able to denitrify the water column and buffer against water quality degradation. And our group is able to measure that, which is really cool. These pictures down in the bottom left show myself and one of my lab mates, Chelsea Brown, collecting some sediment cores in a marsh and in a swamp forest. We can take those cores back to our lab at the Institute of Marine Sciences in Morehead City, where we can conduct incubation experiments and measure nitrogen fluxes across the sediment water interface. And then we can take those measurements and extrapolate them over the entire surface area of each sampled habitat. So that enables us to estimate the nitrogen regulation capacity for really any given landscape, which in my opinion is pretty cool. To the right is one of our sample sites, which is New Bern, North Carolina. I have mapped some natural systems, including forested and emergent wetlands, in addition to some urban landscape like lawn. And all of that is overlaid on top of Dr. Ludick's AdCirc model, actually, for maximum inundation during Hurricane Florence. And looking at spatial distributions of these habitats within this floodplain and within other floodplains like the 100-year, 500-year floodplains has important implications not only for nitrogen cycling capacity, but also for those other really valuable ecosystem services that might be provided, or in some cases not provided to the community. So summarizing all of this in the broader context of DEEP is that spatial arrangements of natural habitats along coastlines can have substantial impacts on the experiences that coastal residents have during and after major storms. So with that, I will pass it off to Elizabeth.
Thanks so much, Anne and everybody. This has been great. So I'm going to just talk a little bit and come back to the survey and connecting coastal flooding to people. So the map you see now is Ocracoke again, and each of those little red squares is a residential building based on our best guess from the tax parcel data. And layered over it is Dr. Ludick's AdCirc inundation map for Ocracoke during Dorian. The lighter blue colors are less deep flooding, the darker colors are deeper flooding, and so most of the village of Ocracoke was inundated with water that ranged from 4 to 7 feet deep. As Natalie mentioned, we wanted to understand what both the short-term and the longer-term experiences of people on Ocracoke was as a function of Dorian. So we drew a sample of 181 tax parcels. Some of those are empty lots and other things because you can't know really until you get there what it's going to turn out to be. But one of the things that's important is that we get a mix of housing types. So we get mobile homes, but also single family homes and a couple of townhomes. We get renters, but also homeowners. We get a mix of full-time residents and people who are second home owners. And lastly, a mix of US and foreign born by drawing this random sample of tax parcels. We have some very preliminary results based on interviews with about 90 households that we've conducted over the past 11 months. And one of the things we find is the magnitude of damage. So about 97% of our households experienced damage of some form, either to their home or to property that was on their lot. About half the homes in which we've conducted interviews so far were too damaged to actually live in. So really significant disruption. Among full-time residents, about half had water in their homes and about a quarter report moving to higher locations within their home to stay safe. At the time of the interview, and most of these interviews were in the past year, so a year after the storm, about 25% were still out of their original homes and about 75% reported a feeling that life was still disrupted. So the impacts of living through one of these inundation events go on for quite a long time. One of the things that's been really interesting being on Ocracoke and doing these interviews is the incredibly active exchange of help, both giving and receiving among community members. So people helped one another a lot, received a lot of help. Some of the homeowners who aren't there year round provided housing for people who were forced out of the homes that they live in. And this last slide, a picture, just shows you the ferry sort of returning to Ocracoke when it reopened. And just a reminder of what a beautiful place Ocracoke is, and having it, back to being a place that people can visit took an amazing amount of work from all sorts of people. And we're trying to capture both what the damage was and what the long-term process of recovery is through these surveys that we're collecting. What are next steps for DEEP? We've got a lot of work still to do. One of the things is to try to build a model of compound flooding that takes account both of flooding from ocean waters and also from rivers. We want to pull in data on land use. Anne demonstrated a bit of that in her work on Newbern, but also first responder reports, which are another source of information about damage and information from the 2020 census. We're also continuing to collect survey and natural system data in about 20 additional communities. That work is underway, although not as far along as Ocracoke, where we first started. When we've done this, we'll be able to answer this question about how variation in exposure from both Florence and from Dorian translates into variation in outcomes for people and for places. And it's understanding that sort of exposure outcome relationship that we'll be able to feed into developing estimates of the impacts of today's storm and flooding in combination with models of sea level rise and how storms will intensify to try to predict future impacts. So I want to stop there, acknowledging the Creativity Hub funding that we received from the Office of the Vice Chancellor for Research, which has been incredibly important. We also have a grant from the National Science Foundation through the Growing Convergence Research Program. This is work that involves multiple centers and institutes at UNC, and a large team of people from the community, our undergraduate students and graduate students, and also some of the faculty, including the ones you've heard from today. So thank you so much for this opportunity to present, and let me stop there.
Wonderful. Thank you to all of the presenters for sharing your research with us. I hope our audience appreciated just the variety of disciplinary perspectives that are being brought to bear on this issue. We're going to transition now from the presentations to the panel section and open it up for question and answer. And I'd encourage our audience members to ask questions using the box. And as you ask questions, if they are directed at a particular panelist, please let us know, use their name. And I think we're open to questions both. You may have questions about individual pieces of the research for particular researchers, or you may have questions about putting together interdisciplinary research or approaching work like this. So please share your questions with us. I'm going to kick it off with a question for Elizabeth. And this question is about how you pick the communities that you do research in.
Okay, great question. So we started slowly, and because we wanted to build up to the pilot. And Rick, Dr. Ludick, actually had a great idea, which was that we should start with the Neuse River Basin. And there are communities all along the Neuse River Basin that were affected both by Florence and by Dorian. And so we designed the project to start there, start on the coast, but sort of work inland. And so now we're sort of moving up those inland areas. Eventually, what we'd really like to do is get sort of the patchwork quilt of the coastal plain of North Carolina. And so we'll be adding communities as we go and trying to be representative both of the populations throughout Eastern North Carolina, but also sort of the ecological features and environments that are there.
Fantastic, thank you. The next question is for Miyuki and Rick, both of you talk about data and modeling and mapping and all the fantastic geospatial analysis that we can do. And I'm curious if the questioner is curious if the team has been able to employ satellite imagery in any of that work. And if you could talk a little bit about it.
Rick, do you want to go first?
Go ahead.
Sure. So we have certainly explored the possibility of using satellite imagery. Now with the prevalence of satellites and the frequency with which we're getting imagery of a lot of locations, it does seem like an attractive option for measuring or detecting flooding. There are two main constraints, especially as they relate to this type of chronic, so very frequent but short-lived flooding that I was describing. The first is that satellite imagery only captures one point in time. So if you didn't happen to sample at high tide that day, you might have just missed the flood completely. And so only capturing that one snapshot, whether that's per day or per week or per month, does make it more challenging to capture the type of flooding that we're interested in. The other constraint is that particularly for visual imagery, if it rains and that's causing the flooding, it's also likely to be cloudy, which means that your imagery isn't going to be so great. And so I think there's definitely some potential for incorporating it, but for the type of flooding that, again, it might come in and out with the tide, it might be a flash rain event on top of a moderate tide. The approach that we're taking, we have more confidence that we're going to capture more of those events than relying on satellites.
And I'll just add, that's exactly right. From my perspective, we, during an event, for example, oftentimes if it's a storm, then it's covered up by clouds. And so we really can't see what's happening. And then, the flooding of the land may be a relatively short-term process. And so it could have changed a lot between the time that you have an available satellite image and or the clouds cleared. So oftentimes we can't use it for that, but what we do use it for is very important, which is to set up our models. And because we're interested in how the water interacts with the land, we actually have to know a lot about what the land is covered with, the vegetation types, and whatnot. And so we get all of that information out of satellites. We put that into our models so that if water does interact and flood onto the land, we can properly capture the interaction that the water will have with the vegetation. Water moving over a parking lot, for example, can be very different than water moving through a crop or a marsh area or other areas like that. So we do use satellite imagery extensively in setting up our models, just not so much during an event or to specifically try to capture what area was flooded during an event.
Got it. Thank you. Our next question is for the two students who presented, Anne and Natalie. Can you talk a little bit about being a student involved in this work and what the experience was like? And then I'd be curious if you or maybe any of the other panelists know if there are going to be future opportunities for students to be involved in this project.
I can go first, Natalie, if you don't mind. So as far as the students go, well, let me back up. So the really cool thing about DEEP is this really interdisciplinary group of faculty, but their students are equally as interdisciplinary and contributing to the research in environmental science and social science and public policy and engineering. So the grad students and undergraduates are really involved in all of this research. And I know there's a smaller group of us working specifically in New Bern, very interdisciplinary, also engaging stakeholders like resilience planners and stormwater superintendents, et cetera. And there are a lot of components that contribute to coastal resilience. So I'm sure there will be many more opportunities to come in the near future.
Yeah, no, I just want to say I 100% agree with Anne. With the how many different types of students are involved, whether that's undergraduate students or graduate students across all different types of fields. I was one of the first undergraduate students to come onto the DEEP team and help open Ocracoke as a surveyor. But since then, we've added, a few different undergraduate students in different degrees. I'm a social science student with political science and economics, but we have students in public policy, and then we have students in environmental science. And so you have a wide variety of students. And then even more recently, after we've started collecting the data and we've started entering this data, I know that DEEP hired quite a few undergraduate students to help with that data entry, and so they really have involved their undergraduate students in the process, especially Carolina students. And so, if you're in the audience watching and you want to get involved with DEEP, I would highly recommend it, and I would reach out to Elizabeth.
Great, thank you both. I'll move on to my next question is for Mike, and this question is about how your research can be used by local or state government or groups outside of academia. And feel free to share. There might be two questions here. One is, in your wildest dreams of the best case scenario, how should it be used? And then maybe a question of, what's the most likely way that it could be used right away?
So that's a great question. And we tried to layer into our design both outcomes, the wildest dreams and sort of the baseline positive outcome. So the sampling that we've done has been really spatially intensive, and it's focused on areas where people are in contact with the water. So we've captured natural gradients from upstream to downstream in estuaries, but we've also looked in coastal embayments and areas where water quality will be really relevant to people, whether it be in ambient conditions, as we've looked at a lot of times, modest storms as we have quite a bit as well, or big storms as we've yet to be able to capture. I think that the data, even that we've generated so far, is very valuable in that it is more temporally and spatially explicit and allows a better assessment of what the water quality is in areas close to people, especially as we layer on Rachel Noble's work that will be similar sites, but with a whole bunch of metrics that are very relevant to human health. I think that the value will go up. If we do have a big storm, we're in a wonderful position in that we know the seasonal patterns for the year leading up to it. We have a lot of spatial distribution, and we'll be able to say a lot of things about the function of the natural system, which will be interesting perhaps to some state agencies and to perhaps other organizations like NGOs, but a lot of very robust things about what problems that we saw in water quality are attributable to the storms spatially. And then we can connect all of that to all of the data we have on people, all the data we have on natural systems, and hopefully fulfill this big couple natural human system model that we've been aspiring to.
Great, thank you. As a representative of a state agency, I'll have to follow up with you afterwards about how we can use the data and lift up the work that you're doing to support decision-making.
We'd love to, for sure.
This next question is for Elizabeth, and the question is, how translatable do you anticipate this overarching model to be to other locations around the Southeast? Or is it more specifically for Ocracoke or maybe only communities impacted by Dorian or Florence?
Yeah, that is a fantastic question. I think that it will be translatable to other types of other communities in the Southeast for a couple of reasons. I mean, one is that Dorian and Florence were very different types of storms, as Rick was discussing. And so by having data about the impacts from each of those, we'll understand something about sort of the more classic hurricane with large storm surge, but also about these slow-moving, massive hurricanes that stall and dump a lot of rainfall that then affects communities sort of throughout the eastern third of the state. Mebane is important because it's going to be our most urban site in the current framework, but we'd like to expand to other urban areas as well. So in terms of how these events affect people, I think we will be able to say a lot that's translatable across sites and across types of storms. For the ecological settings, we'd have to go to Mike and ask him about, how well our results might translate to Gulf Coast settings or something like that. The habitats, of course, that are in the warmer parts of the Southeast that we're not capturing right now. And it would be wonderful to sort of develop some partnerships with other places that wanted to try some of the same types of work. Mike mentioned being sort of well set up when another storm comes along, and that's one of the things that I think, having a questionnaire that we've designed, we can adapt it as new events occur and get it into the fields and sort of ready to go, and then also add in sort of smaller data collection efforts to address particular topics. So one of the things we've been really trying to do is build an infrastructure platform as well as collect the particular data that we're working on right now.
Got it. Thanks, Elizabeth. Our next question is for Mike. This question is, what can be said about non-point versus point sources of nutrient elements in our estuarine and coastal waters as related to algal bloom problems? Years ago, it was postulated that we would need a 30% decrease in nitrogen coming down our rivers. Where are we now with that projection with respect to water quality?
So I'll start off by saying that we were not specifically targeting the empirical connection between nitrogen reduction and potential problematic algal blooms in this work. But I do think that our work is really relevant to that class of issues because we're sampling during ambient conditions where it hasn't been raining, and then during storm conditions. We have a good sense within the study area, which I apologize, I failed to mention, was the Newport River estuary right around Morehead City. We do have a sense for the importance of sources during wet and dry conditions. And as it looks so far, a lot of the important sources are similarly important in dry conditions. So that points to point sources being important. One of the things we've started to think about following those results were how sources change as big events happen. So you could imagine the map that Anne showed of New Bern and all of the different potential sources that exist in those areas that Rick's flood model showed flooded, and how that changes the dynamic of nutrient delivery off the land into the water, and how it also, as Anne talked about, changes the processing of nutrients in the habitats that are also being flooded. So I think that what we're seeing is an importance in this study area, at least, of point sources, of the sewage treatment plants being significant sources of nitrate. And we're not yet seeing the huge responses in chlorophyll, which would be associated with excessive algal growth. This is a system, the Newport, that has been not as impaired as some others like the Neuse, which is the original spot of the 30%, the need for 30% reduction in nitrogen loading.
Okay, thanks, Mike. This next question is for Miyuki, and it's about that image that you showed us in your slide yesterday where we can see flooding. I think it was flooding over a parking lot. I think it was in Beaufort. And you showed us where that was on the graph. And I'm wondering if you could talk a little bit more about that flooding, what caused it, and how it is related to climate change.
Sure. So there's actually, this was not an isolated event in Beaufort. There were very high water levels all up and down the North Carolina coast. Highway 12 on the Outer Banks was closed down for quite a while due to these high water levels. And one way to think about the connection to climate change here is that we know that human greenhouse gas emissions have contributed to somewhere in the neighborhood of 8 to 12 inches of sea level rise already. And so if you think about that graph that I showed and take off that foot or so of climate change related sea level rise, then we would have gotten much, much less flooding in Beaufort. There would have been a lot of places that probably wouldn't have flooded at all without that added boost from climate change. And so what we're seeing now is, so what happened over the weekend is it was supposed to be a pretty high tide, some of the highest tides of the year. And that just happened to coincide with a tropical system offshore that was pushing really strong winds towards the coast. So we had normally higher tides projected on top of all of this water being blown towards our coast. And we ended up with what was really, really extremely high water levels without even a storm really threatening land in the way that we usually think about the risks from hurricanes. And so sea level rise in that way is providing this higher, it's almost like a launch ramp now for all of the storms and all of the tides and all of these weather systems where they're all starting from this elevated water level. And so what we expect to see is more events cause flooding, and more of that flooding gets farther inland than it would otherwise without those higher sea levels.
Great. Thank you, Miyuki. We got a really great audience question, and I think it might be a good one for someone else to actually ask. So Rick, would you be willing to ask it?
I'll be happy to. I think this group is certainly excited about the research, but we're also clearly very committed to research that helps address needs and helps hopefully guide policy and hopefully makes a difference in the future. For the citizens of North Carolina that live near the coast and also other areas that can learn from us. And so this question is a great one in that regard. And I'm asking it because I think Amanda might even have an opinion on it. And so I'd love for her perspective. And that is, as we work through this project, as we try to learn more about the issues that are involved, the question is, if the end result of this impressive research calls for radical change in prevention and mitigation efforts, how prepared is the state and the North Carolina Office of Response and Recovery to resilience and recovery? Hey, you'll get that. You'll fix that for me. Sorry. Anyways, to respond to new strategies to protect the coast and aid the residents there. So are we ready for the results that we might be finding in this study?
All right. Well, that is a really great question. I work for the North Carolina Office of Recovery and Resiliency. We are a division of the Department of Public Safety, but we work closely with a lot of other state agencies and have a role that extends across state government to support climate resilience work. And this question is really important, and it doesn't have an easy answer. I think if the Chief Resilience Officer could snap her fingers and change a lot of things to align with what we see as best practices emerging from the research, that would be amazing, but the job didn't come with a magic wand. So change can be very difficult. So I want to mention a few things in response to this question, because it's a really good one, and we get it a lot. And I've sat on the side of the researcher and wondered why the state is doing things in certain ways and seems, feeling kind of incredulous about it. And then you sit on the side of the state and you're like, oh, okay, I get it. I see why this is happening this way. So one thing I really want to highlight is the gap between research and policy or action on the ground. And it's a really big challenge that I see, because translating fantastic research science or research findings into actionable and truly actionable things like legislative language, it's a lot of work. And I think that sometimes on the state side, we assume that the researchers will do it, that the academics will do it. And on the academic side, we assume that the state can take that on. And really, it's not too many people's jobs to actually do that. I'd say maybe our fantastic folks in Extension are the best example of this. But it's actually the strongest, best research may not just immediately have an obvious next step, and that next step needs to be written and developed and vetted. And it may be that it's not anyone's job to do that, and that's a problem for us to get there. I think that in general, we see that in North Carolina, there is a common acknowledgement that what we are doing is not working because of the level of impact that we've seen in recent years. And that is not the same across the United States. So North Carolina, in many respects, is in a leadership position, and we have an advantage with respect to addressing climate impacts because of that sort of common agreement that we need to do something. It's the what that we need to do where things get really complicated very quickly. So I will say that in general, we see the beast of government moving really slowly in all respects. But then in other moments, we've seen very urgent response to challenging situations. Take the pandemic, for example, the way that, as a society, we completely changed our ways of life, and a lot of new policy and new government capacities were created very quickly to address the pandemic. That's an example of when faced with a really difficult, urgent challenge, we do have the capacity to find it within ourselves to change, to rise to the occasion. So I think there's some hope in North Carolina, and the challenge is really big. And I would encourage everyone who sort of sees what the solutions ought to be to really come to the table and work with government stakeholders. It takes a lot of time to build relationships and co-create those kinds of solutions to figure out what is feasible in our political environment and what are the wildest dreams, and let's make sure they're on the table too, so that we can continue to work towards them over time in terms of bringing the research into policy. So there are a few thoughts about where the state is with respect to acting on all of this fantastic research.
That's great. Does your office have an outreach arm? Are there, as you just said, as we come up with good ideas and want to engage, is there an obvious place we go to find that?
There's not, as I mentioned, it's unfortunately not anyone's job. I mean, we have a external affairs person, but primarily we think of that as external affairs with local governments, with local stakeholders. That said, my team focused on resilience tries to be very outward focused or outward looking. And we'd be happy to have conversations with any and all of you. We're especially talking a lot about resilience data these days and how we can make all the data out there more usable and accessible to stakeholders that might want to apply that data. So certainly I welcome the opportunity to speak with any of you. Do we have any final questions? It looks like we do not. So unless there are any final comments from any of the panelists, I think we will wrap it up. Thank you all for joining us today. I hope you enjoyed this broadcast from such a fantastic group of researchers working on a critical problem facing the state and facing the world. So thank you for your time today. Take care and have a good weekend.